Hello everybody, welcome back to this channel. So today we're going to talk about a very important topic in in engineering in general, which is the Bode plot. Although this very simple tool, it has been very popular for a long time until today. And in this course, we're going to use this very on the surface, but in the controls, we are going to use Bode plot very much. So the text had very little discussion about this, so I will dedicate one lecture on this. Basically, the goal is to be able to approximate the Bode plots, the Bode plots of a transfer function using straight lines. Okay, and let's get started. So today, I think I have three topics. The first one is to introduce the Bode plot and also the kind of the basics about the logarithm, and some of you maybe already forgot. So, and the second one is to see the Bode plots for three different very basic functions. In that case, that does not involve the approximations, and the third one would be see the approximation with the transfer functions, how we're going to approximate a couple of those. And then we're going to look at an example. So let's get started. So the Bode plots is really a very simple concept, right? If we have a transfer function at Ts, and we're going to replace S by j omega, right? The reason we replace this by, we're looking at this function because this function has a lot of information in terms what the system can do to the sinusoidal input and to get the output, the sinusoidal steady state output, right? So this if we put absolute value, and then we take this dB, which denotes this 20 log base 10 of this gain function, and we take the, so this is in terms of the dB, and we plot this one. We plot this, so the gain function, in dB, which is Tj omega dB. This is kind of the notation we'll be following to be consistent with the text. And so in this we plot this is plotted against the angular frequency omega. The omega is also in log scale. And so in this case, we basically get all the information and any frequency, how much is the gain in terms of dB. The reason we use dB is that because then if you have two transfer functions, right? Because the property of the logarithm, and let's see if you have a two multiplication, and then that becomes the addition, right? So log A plus log B. In this case, the A and B should be both positive. And if you have log A over B, and then you have log A minus log B, right? So, and if you have log 1 over A, in that case, that's going to be equal log 1 minus log A, which is equal negative log A. Just want to put this information here in case you forgot. Okay, so this is about the gain plot. So you plot this with the against the omega angular frequency, and we also plot the phase. The phase function. The phase function we call. The phase function is basically we take the angle or the argument of this Tj omega. So we denote that as theta omega, which is just an angle with Tj omega, right? So let's see if we have very simple transfer function. Let's see, in that case, we have the simple one. We're going to look at this later. So in this case, the theta omega is going to be equal, the angle with Tj omega is, so in this case, just the angle of j omega, because we replace s by j omega. So in this case, this is going to be equal 90 degrees. Remember the j is equal to e to j 90 degrees, or that's just equal 90 degrees. So that has the phase angle 90 degrees. Okay, so that's basically the little very short introduction of Bode plots, and we're gonna see a few the plots for the basic functions. So today's lecture really had very simple math, but if you understand the concept, this is very useful tool for the future when you do control. And in the past, I had students when they took the higher level courses, they asked me about this lecture because they're using that and they couldn't find out. But in any case, so let's get started. Let's start a new clip, and I'm going to see you in a moment for the basic transfer functions.